Hello, welcome. This is an Edexcel C4 January 2007 past paper. Obviously past paper. Now, what I've done is obviously I've changed the angle that I record it from, just to see. I had a bit of a change of thought. So, I mean, you know, if it's not popular, then I'll obviously change it back. But you know, whatever. So anyway, in this video, as I said, I'll just be going over question 1, and I've actually got a handout here. This question is, sorry, just get the, really, it was going to be slick and smooth and have it straight away there, but obviously I don't. It's just a case of differentiating, oh sorry, not differentiating, binomial expansion, for God's sake. It must be the view that's different and it's messing with my head. Anyway, so in this question, it's just asking us to expand this given function of x, which I'm going to draw right on the board shortly, up to and including the term in x cubed. Okay, now obviously, if it's when you get a question that's just as simple as this, in terms of just expand this in terms of up to the terms of x cubed. As I said, this could have easily been in a C2 paper, because in this specific question there's no mention of the C4 validity, really. That's the only difference. So anyway, we're given the function of x, so given this function of x, I'll call f of x, is equal to 2 take 5x all to the power of -2. Or you could say, oh sorry, we're not giving it as that, we're actually giving it as 1 over 2 take 5x all squared on the bottom. Now, I probably should have started from that. I can't bother restarting this video. Okay, so when you get anything as 1 over, the only thing you move to the top is any x's or anything. We don't generally like x's being on the bottom. I don't like x's at all, but you know, we don't like them on the bottom. We have to move them up to the top. Now, we don't move the numbers. However, it's asking us to do a binomial expansion, so it's clear that we're going to have to have something like this. We can't expand that with a binomial expansion. You might think, okay, well, I'll expand 2 take 5x and do 1 over it. Well, so you could try that, and if you get the same answer, then that's a valid theory. But as I said, this is the way we want you to do it. Right, as that's essentially 1 over 1 times 2 take 5x to the power, or to the power of 2, or squared. You just take this, the 2 take 5x all to the power of 2, move it up to the top, so you get 2 take 5x all to the power of -2. I might have overcomplicated that, but as I said, hopefully you kind of understand where we've got that from. Now, you could expand that in terms of the, oh wait, no, actually, sorry, you couldn't expand that in, there's 2 binomial expansion. Now, the one that I'm going to do is the only one you really should do at C4. The other binomial expansion is a bit pointless, and can't be used for this expansion because we've got a negative power, and the other binomial expansion, which doesn't, when you don't put it in a form, when it's not in the form 1 plus ax to the power n, the power has to, when you expand something that isn't like that, the power has to be a positive number and also an integer or a whole number. Now that's obviously not, now it's not in the form 1 plus ax, but it's got a negative power, so we can't use that other method. I mean, you shouldn't really, you should only use the one where it's in 1 plus ax to the power n. You should always expand it when it looks like that. But as I said, that doesn't look like that. So what we've got to do is make it look like that. Now we can't just go up to maths and go, you're going to change, and just imagine it changing and put 1 take 5x all to the power of -2, because that's changing the whole function. So what we do is we have to take, because we're not bothered about this -5x, we're going to have to change it at some point, as I said, but we don't have to make that anything, because it's 1 plus ax, a can be anything, so the only thing we're concerned about is this 2. So in essence, we need to divide all of the inside of this function by 2, or in other words, take out 2 as a common factor. But because this 2 was originally inside the bracket, everything inside that bracket had a power of -2. But they've just sort of factorised it to the power of -2, if that makes some kind of sense. So, in essence, we still have to carry this power. When we take 2 outside the bracket, we have to take the -2 as well. But, never mind. So, basically what I'm saying is this, you put 2 to the power of -2 times 1 take. Now this 5x, because we've divided all of the inside of this bracket by 2, we have to divide the 5x by 2 as well. So it's 5x over 2 or 5 over 2x. Now I wouldn't put it as 2.5x because, well, that's going to be quite hard to, when you come to cubing that as well. You may be able to, obviously you would do it on your calculator, you've got a calculator in C4 exam, so why not? But it's nicer to keep it all in fraction form, okay? So, you know, if you don't accidentally put some wrong numbers in your calculator. Right, so anyway, if we work this out, simplify it down, so we get 1/4 times 1 take 5x over 2 all to the power of -2. Now that's great, that's in 1 plus ax, but obviously we've got 1/4 there. Now, you can do this in a number of ways. As I said, you can just, well, not really a number of ways. What I would do is, I would just ignore this 1/4 for the moment. I'll obviously put it back in a minute, but we can't, all we can do is just expand this 1 take 5x over 2 all to the power of -2, and then times the answer of that by 1/4, okay? So, as I said, you can, the maths is the same, but you can make it look slightly differently. Okay, so it's 1/4 times 1 take 5x over 2 all to the power of -2, okay? And I think the formula is in the back of the book, but it's always nice to give it a bit of state it somewhere in your work, okay? So 1 plus ax to the power n is equal to 1 plus an plus brackets n times, could say n times n take 1 over the factorial of 2, which is 2 times 1, times a squared, and you can continue that, so the next part would be n times n take 1 times n take 2 over the factorial of 3, which is 3 times 2 times 1 times a cubed. Okay, as I said, you didn't need to write the binomial expansion down, but it's always nice just to refer to it, so you have to keep flipping back and forwards. But maybe that's just me being a weirdo, okay? So therefore, but because this is times by 1/4, this 1 plus ax, I know it's 1 take 5 over 2x, but it's the same thing. Therefore we times this answer the expansion by 1/4, so we'll just put 1/4 there in and sub in the rest. Now what I would do, as I said, because I've gone to the extremities of actually writing out the equation, you might want to write what a and n are. Now don't be put off even though it's 1 plus ax, the a is actually associated with the x, because if you did this expansion without the x's in, when you've just left a as say -5 over 2, because that's what it looks like from this expansion, then you would end up with an expansion with no x's in, and 2 take 5x all to the power of -2 must expand to have some x's in it, otherwise it's just, it won't make sense. So you have to remember the a is, even though it says plus ax, the a is associated with the x as well, okay? So, I mean, that's logic, but it's very easy for students to just miss that. Okay, so it's 1 plus an. Now a, as we said, is -5. So, as I said, what I would do actually is write what a and n are. So a is -5x over 2, and n is equal to -2. So it's 1 plus -5x over 2 times -2. Now obviously you know that comes to plus 5x, but it's always, as I said, it's just nice to leave it there so you can, if you make a mistake, the examiner can see where you've gone wrong. And then it's plus n, so we know n is -2, and it's take 1, so I know it's obvious, but it becomes -3. It doesn't become -1. And then, okay, so it's -2 times -3, and that's over 2 times 1. Now that's obviously just 3, but as I said, you know, keep it standard. And then it's times a squared, so it's -5x over 2 all squared. Okay, and it wants it up to the term in x cubed, so we just carry on doing this method. So it's -2 times -3 times -4, because that's n take 1, n take 2, over the factorial of 3, which is 3 times 2 times 1, times a cubed, so that's -5x over 2, all cubed. Okay, and that was just a case of simplifying it down. Now, what I would do is simplify this term, all of these terms, and then times it all by a quarter. I wouldn't just try and go 1 times a quarter and then try to work this out in your head, because obviously, some people try to do that, they may make mistakes. But obviously, because you're watching this, you know what you're doing. But as I said, it's just do it for simplicity. Okay, so obviously simplifies to 1, weirdly enough, and then as I said, that's plus 5x, and then we said 2 times 3 was obviously 6, and then that simplifies down to, double negative, so it simplifies down to 3, and then when we square the -5x over 2, we square the top and the bottom, remember? So it's 25x squared over 4, but we times it by 3, so therefore it's plus 75x squared on 4. Okay, this next part, well, it's 2 times 3 times 4, and then over it's 3 times 2 times 1, so the 2 and the 3's cancel out, and obviously the 1 cancels out with itself, so therefore we're just left with -4 times. Now, if you're struggling to keep track of where we're going here, on each of the little terms you might want to write down what they are, instead of writing 3 times 25x squared over 4. You can keep the idea going like that. I do apologise, you'll have to ignore the phone call. Hopefully someone will pick that up in my house, but that's not given. So anyway, as I said, you just sort of cancel out the 2 and the 3's and the 1. So therefore we're left with -4 times -5x over 2, all cubed. So 5 cubed, well, 5 times 5 times 5, so it's 25 times 5, which is 120. If that's wrong, I'm going to have to shoot myself in the foot. I do apologise, but I just want to do it right. 125. I've shot myself in the foot there. So 4 times -125 x cubed over 8, remember, because it's 2 cubed. I didn't remember that, but whatever. Okay, so it's -4 times -125 x cubed over 8. Obviously, them two double negatives cancel, so you just do 4 times 125 over 8 in your calculator, and you get 120 plus, so plus 125 x cubed on 2. Okay, and it's just a case of expanding this out now. So a quarter times 1 is obviously a quarter, and then 5x times a quarter is obviously just plus 5x on 4, and then we're left with plus 75x squared on 4. Okay. Oh, sorry. This 75. What? Yeah, it's wrong. Is it? Sorry, I do apologise. One second, let me just double check if I've gone wrong somewhere. No, I don't think so. Yeah. No, I haven't gone wrong. I don't know what I was doing there. Okay, so this 75x squared, so it's over 16. Just got it wrong in my answers. I put that as 2 because I completely ignored myself. And then you do 125x cubed over 2 times a quarter. Now, you could write that as 125x cubed over 8. However, that cancels down. So what you could either do is you could write this out as plus 125x cubed over 8, and then rewrite this entire thing out and with the simplified 125x cubed over 8. Sorry. Oh wait, can you simplify that? I thought you could. No. Sorry, I genuinely thought you could simplify 125 over 8. Turns out you can't. So, sorry, yes. Just plus 125x cubed over 8. So I do apologise about that. I didn't know where my head was then, but definitely wasn't in the math zone. So anyway, that's worth 5 marks if you eventually get that right with my help. I do apologise about the phone, but it just turns out no one in my house is bothered enough to actually pick up the phone. So anyway, thanks for watching, and we'll see you in the next video.